In this lecture, we'll discuss Mealy machine and the Moore machine. So first we'll define what is a Mealy machine. In case of Mealy machine, the output function, suppose z of t is a function of present state, say q of t, and the present input x of t. So we can write z of t, that is the output function, is a function of, that is lambda, q of t, the present state, and the present input, that is x of t. And this lambda is basically called the output function. Output function. So the value here, the output function z of t, it is basically the value. So the value of output function is, so output function lambda is basically the output function. And this generalized model is basically known as the Mealy machine. So this model is basically called the Mealy machine. Now if the output z of t is basically depends only on the present state, that is, if the output function, that is z of t, basically is a function of only the state, only on the present state, and is independent of the current input. So we can write z of t is equal to lambda q of t. This model is known as a Moore machine. This model is basically known as Moore machine. So basic difference is the output function. In case of Mealy machine, it depends on both the present state and the present input, that is qt and xt both. If it depends on both, then we call it as a Mealy machine. But if it depends only on the present state and is independent of the present input, then we call it as a Moore machine. Now, formally, we define Moore machine. So, definition: a Moore machine has a 6 tuple. Yeah. The tuples are q, sigma, del, delta, lambda, and q naught, where this q is a finite set of state. And sigma is a input alphabet. And delta is the output alphabet. And this delta is the transition function transition function, that is sigma cross q into q. Fifth, lambda is the output function mapping q into delta. And six, q naught is the initial state. Initial state. So these are the six tuples in case of Moore machine. And in case of Mealy machine definition, so Mealy machine also has six tuples. So a Mealy machine has six tuples q, sigma, del, delta, lambda, and q naught, where all the symbols except this lambda have the same meaning as we have defined in the Moore machine. So lambda, this lambda, as we have mentioned that lambda is the output function. Here this output function lambda is mapping from sigma cross q into delta, because in Mealy machine it depends on both the input as well as the present state, and the output is delta. But in case of Moore machine, it depends only on the as we have mentioned, it depends only on the here it depends only on the state, present state only. Now we'll give an example how basically Moore machine looks like. But before that, we'll give some notes. Note: for Moore machine, if the input string is of length n, input string is of length n, the output string is of length n plus 1. The first output is lambda q naught for all output strings. The first output is, that is lambda q naught. The first output is lambda q naught for all output string. But in case of Mealy machine, if the input string is of length n, so this is for Moore machine, and uh, if input string is of length n, the string length is of length n, the output string is also of the same length n. This is in case of Mealy machine. So this is basically a note about the Mealy machine and Moore machine. Now we'll give example how a Moore machine as well as the Mealy machine looks like. Uh, Example, present state, present state, and here it is the next state, and we call it as a delta, and the output. So in case of next state, here a equal to 0, and here suppose input a equal to 1 and output is lambda. Now the present state q naught, it is initial state, and it is a q3, q1, output is 0, q1, q1, q2, 1, q2, q2, q3, 0, q3, q3, q naught, and 0. So this is an example of Moore machine. It is a Moore machine. Now, why it is called the Moore machine? Because the output, that is here the output 0, is depends only on the present state and is independent of the present input symbol. So that's why it is called the Moore machine. Now suppose we have to process an input string. Suppose we have to process an input string, process input string 0, 1, 1, 1. Now we have to process this string and we have to write the entire sequence of states and what will be the output. So we have to start from q naught. So you are in q naught, and by taking input 0, your input is 0 and will move to states q3, right? And what is the output when you are in q naught? Because output depends only on the present state q naught. So lambda q naught basically gives you output 0. Now if you are in q3 and your input is 1, q3 your input is 1, you will move to q naught. So you will move q naught. Now what is the output while you are in q3? So lambda of q3, at that time your output is 0. While you are in q naught, your input is 1. Q naught, your input is 1, you are in q1 state. What is the output? Q naught, lambda q naught is basically, it is also 0. While you are in q1 and your input is 1, you are in q2 state. While you are in q1, what is the output? So lambda q1 is basically equal to, q1 is basically 1, and while you are in q2 state, so lambda q2 is basically 0. So for the input string 0, 1, 1, 1, what is the output string? So the output string is, what is, if we concatenate all this, it will be 0, 0, 0, 1, 0. So as we have mentioned that in case of Moore machine, if your input string is of length n, the output string is of length n plus 1. For the input string lambda, the output for input string, we assume that input string lambda, for input string null or string of length so for the input string null, the output is lambda q naught, which is basically is equal to 0. That we have considered is the first output. So lambda q naught equal to 0. Now we'll give an example of Mealy machine. So the Mealy machine in case of Mealy machine, we write the present state and then next state, and in case of next state we have to write state, obviously input, or there should be input. So now suppose your input is equal to 0 and another input is equal to 1, and in that scenario here the state and the output, here also the same state and output. And say suppose q1, here it is a state, suppose q3, here it is a 0, here q2 it is 0, and it is a suppose q2, q1 1, q4 0, q3, suppose q4, and it is a q2, q4 1 1, and it is q1, and it is q3, it is suppose 1 0. So in case of Mealy machine, as we have mentioned, that the output, that is the output, this output depends on both the present state and the present input symbol. That means if you are in q1, your input is 0, at that time the output is 0. So the output is basically is a function of both the present state as well as the present input. Now we process the string. Now process string, suppose 0 0 1 1. If we process, now the entire sequence of states will be, if you are in q1 and your input is 0. So if you are in q1 state and your input is 0, you will move to q3 state, but your output is 0, as we have mentioned here. Now if you are if you are in q3 state, again your input is 0, then you will move to q2 state and your output is 1. Now if you are q2 state and your input is 1, you will move to q4. You will move to q4 states and output is 0. Now if you are in q4 state and your input is 1, you will move to q3 state and your output is 0. So the output produced is basically 0 1 0 0. So output string is basically 0 1 0 0. Now already we have mentioned that in case of Mealy machine, the length of string, input string, the output string length, both are same. So in case of Mealy machine, we get an output only one application of an input symbol. If the input string is empty, then the output is also empty in case of Mealy machine. Now we'll convert from one machine to another machine. First, we convert the Mealy machine to Moore machine. So convert Mealy machine to Moore machine. Suppose we have a Mealy machine. Present state, next state, and in next state, suppose input is a equal to 0 and input is a equal to 1, and we assume the state and here the output, state and output, and suppose this. Now suppose q1, here it is a suppose q3 0 and q2 0, and q1 it is 1, sorry, q1, no, q2, it will be q2, suppose it will be q2, and here it is a q1 and 1, it will be q4 and 0. Now q3, it will be q2 1 and it will be q1 1, and it is suppose q4 and it will be q4 1 and it is q3 1. Suppose this is the Mealy machine. Okay, now we have to convert this Mealy machine to a corresponding Moore machine. So a few steps are there. What? First, we have to find those states which have more than one output associated with them. For example, so initial first rule is we have to find out those states which have more than one output associated with them. For example, look, Q3, sorry, it is key 0. Q3, it is a 0. Now, 0, 0, okay. Now, look, Q3, the output is associated is 0. Here also output is associated 0. So there is a unique output for the state Q3. But for Q2, so for Q2, in this line, the output associated is 0. But here the output associated is 0. Here the output is associated with 1. So one output is 0, another output is 1. So we have seen that Q2 is associated with more than one output. Similarly, Q4 is also associated with more than one output. Look here, this is a Q4. Q4 is associated output is here 1. Here associated output is 0. So we can write that Q4 associated output is 0 and 1. First we have shown, and remaining state, that is Q1, same output, and Q3 also the same. Next is we have to create two states for those states. Like in this case, we have to create two states. Suppose Q2 0 by incorporating 0, and another state will be Q2 1. Here also Q4 0, another state will be Q4 1. Right? Now we have to create an empty Moore machine with this newly generated states. What are the newly generated states? Q20, Q21 and Q40 and Q41 are the newly generated states. Now we can write, that is present state, the next state, here input is a equal to 0 and here the input a equal to 1, state, and here the output, state, here the output. Okay. Now starts from Q1. Now what are the new steps? First Q1, then Q2 is basically generated two states. One is the Q2 not, Q2 0 and Q2 1. Then Q3, then Q4 0 and Q4 1. Now write the transition. Q1, next state is Q3 and we have to write 0. And here state is Q2, but Q2 is a newly generated state. So we just write Q2 0 with output 0 0. That means we assume that its output is associated is 0. That's why we have write Q2 0. Now Q2 0. So what will be this Q2 0? It will remain same Q1 and output associated is 1. But here it will be Q4 0 and output is 0. Right? Similarly Q2 1, it will remain same and same, and it will also be Q4 1, Q4 0 is also 0. Q2 1. So in case of Q2 1, it will remain same Q1 and output is 0 and Q4 0 and output is 0. Now Q3, in that case Q2, so Q2 is newly state, so we can write Q2 1 because output associated is 1, so output is 1, and here Q1 and 0, 1. Now Q4 0, Q4 0, output associated is 1, so we can write Q4 1, output is 1, and it is a Q3, its outputs remain the same, so we can write 0, and for Q4 1 it will remain same Q4 1, output is 1, and Q3 it will be 0. So now the concept is basically the Mealy machine, as we have shown that the output depends on the present state as a present input, but in case of Moore machine, output depends only on the present state. Right? So now from this table we just remove these outputs and create another table which will be look like this: present state, right, and next state, a equal to 0 and a equal to 1. Another column will be added here, just output, because we know Moore machine there is an output which depends only on the present state. Right, now just write all the states of this table Q1 to Q4 1. So now here Q1, Q2 0, Q2 1, Q3, Q4 0 and Q4 1. Now write all the states as we have obtained in this table for a equal to 0. Q3, Q1, Q1, Q2 1, Q4 1 and Q4 1. Just write the states. So we can write Q3, then Q1, then sorry, it will be Q1, then it will be Q1, it will be Q21, it will be Q41, and it will be Q41. And for A equal to 1, the states will be Q20, then Q40, Q40, Q1, Q3, and Q3. So right here the states, it will be Q20, then Q40, Q40, Q1, Q3, and Q3. Now the output. Look, Q1 in the table, in case of Q1, there is a unique output 1, right? So we just write this output here, 1. Now for Q20, in this table, the Q20 is associated with output 0, unique output. Anywhere where when you find in the table that Q20 state is there, then its output is 0. When there is a Q21 state, its output is 1. For Q3, the output is always 0, but for Q41, the output is 1, and Q40 output is 0. So in this manner, we have to write. So now for Q20, obviously output is 0. For Q21, output is 1. And Q3, the output is always, we have seen Q3, for Q3, output is 0. So Q3 output is 0. And Q40 output is 0, and Q41 output is 1. Okay. So this is basically the Moore machine corresponding to the Mealy machine that we have given in this table. So it is a Moore machine. Moore machine. Now, one concept for Moore machine, as we know, for the input input empty. So as the first output is 1, clear, here the Q1 state is the initial state, and here the output is 1. So for Moore machine, if your input is empty, that is null, then output is also lambda of null is basically, we assume that it is a 0. Yeah. So for Q1, the output is 0 or null, then it is not necessary to add the initial state, because look here the Q1 state is initial state, but the output is 1. But for Moore machine, to input null empty, we have to add an new state. We assume that new state is Q0, and whose state transition are identical with this Q1 as mentioned in this table, but whose output will be 0. So we have to add an extra state here, because the initial output for Q1, it is a 1. So we just add an extra state here, Q0. We make this state as the initial state, whose transition will be identical to Q1. So we can write Q3, and it will be Q2 0, but its output will be 0. And we omit this. Right. So now it is the complete Moore machine. But if Q1, but for Q1, the output is 0 or the null, then it is not necessary to add an extra initial state that we have added here. But if the output is 0, at that time it is not necessary to add an extra state Q0. So what we have seen here, as we know that for Moore machine, if your input is this, then the output is 0. So at that scenario, for lambda for the state, suppose it is a q naught, so it should be q naught equal to 0, or q1 should be 0. That's why we have added an extra state q naught, and whose transition is identical to q1, but output is 0. So this is the Moore machine. Now we convert Moore to Mealy machine. Moore machine to Mealy. Suppose the Moore machine given is like that. Present state, next state, a equal to 0 and a equal to 1, and here the output. So here it is a q naught, output is 0, is q3, q1, 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 q2, 1, q2, q2, q3, 0, it is q3, q3, q naught, 0. So it is a Moore machine. Moore machine, and we have to convert it to corresponding Mealy machine. So in case of Mealy machine, you know that the output depends on both the present state as well as the present input. So we can write the table as present state, next state, a equal to input, a equal to 0 and a equal to 1. Here it is a state and output. Here also state and output. Now we convert. So now q naught, what are the states in the present state? We have to write q naught, then q1, q2 and q3. Now by taking 0, right, by taking 0, the next state q3, q1, q2, q3 also remain the same. Here states, so it will be q3, q1, q2 and q3 remain same. But what will be the output? Now if for the input 0, if you are in q3 state, so what is the output of the q3? Well, it is a 0. Clear? So if you are you are in q1 state, next state, okay, so output depends on the present state as well as the present input. So when look into the Moore machine, so q naught, the output is 0. For q1 output is 1, q2 output is 0 and q3 output is 0. So in this case also we have to write for q naught present state and your input is 0, but you will go to the state q3. Here the output will be, that is q3, but the output will be here 0. Now for q1 output is 1, q2 output is 0 and q3 output is again 0. Similarly, for a equal to 1, input a equal to 1, what are the states? It will be remain same, q1, q2, q3 and q naught. So now for q1 the output will be 1. Now for q2 output will be 0 and for q3 output will be 0 and q naught output will be 0. So this is the conversion. So when we convert Moore machine to Mealy machine, so it is a Mealy machine. Mealy machine, we have to convert in this way. So present state will remain same. Next state, there will be two inputs, a equal to 0 and a equal to 1. And if for every input, there will be state and output, state and output. And state will remain same for input a equal to 0 and for input a equal to 1, the state will remain same. But what will be the output? Output we have to check from here, Moore machine. So if you are in Q not state, then output will be 0. Yeah, if your state is Q1, then output will be 1, Q2 0 and Q3 0. So in this case, Q3 is your state, so output will be 0. For Q1, output will be 1, Q2 output will be 0, Q3 output will be 0. Here, as it is Q1 state, so output will be 1, Q2 output will be 0, and Q3 output will be 0, and Q1 not output will be 0. So this is the Mealy machine. Now we can uh, reduce the number of states in any model by considering the states with identical transitions. That is, if two states have identical transitions, then we can delete one of them. So thank you.